Okay, on this problem here, we're going to use integration by parts again. We're going to start off with our u being the 3 sine x. So our dv would have to be the e to the 2x and the dx here. So then you got to figure out your du, so you have to take your derivative. Derivative of sine is cosine, and then you got to remember your chain rule, so that's why there's a 3 in front. Here you have to integrate, and well, that would give you 1/2 of this, because remember, e to a power, when you integrate or differentiate, is always e to that same power. But we need to have a 1/2 here to undo the derivative of the exponent. So now we want to go ahead and rewrite this. We want to go our u, which is our sine of 3x, and our v, so here's your u, here's your v, minus the integral of your v, and your du. So front part doesn't change. I'm going to just go ahead and take that 3 with the 1/2, put it in front of my integral sign. So we have this. Well, doesn't necessarily really look any better than what we started out with, but it doesn't really look any worse either. It really looks to be about the same. So we're going to use integration by parts a second time. So we're going to still have our original problem here. Bring down the u times the v that we had. Bring down our negative 3 over 2. And just do the integration by parts on the highlighted stuff. Well, we're going to choose stuff very similar to what we started off with before. We're going to let the u be the cosine of 3x, and the dv be our e to the 2x dx. So therefore our v is the same thing we had before, because our dv was the same. Now we got to differentiate this, so we're going to get a negative 3 sine of 3x. The 3 comes from the chain rule, derivative of the inside. So now, just on this highlighted part is where we're doing the integration by parts. So this stuff right here, I just brought down. This stuff right here, I just brought down. So now all I'm doing is just integration by parts on this. So I need to have all that in big brackets. I got to do my u times my v minus the integral of my v times my du. So this is my v, this is my du from what I have up here. Well, now we need to go ahead and do some simplifying. If we go ahead and distribute this negative 3/2 through to this, get a negative 3/4 of that. Now I got to distribute this negative onto this, which makes it positive. But notice I have a negative here, so I have a negative onto a negative with a negative out. 3 negatives makes it negative 9/4. Because once here we have a 3 times a half, which is 3/2, times your other 3/2 gives you a 9/4. Well, you'll notice then that what we have right here matches exactly with what we're trying to get over here. So, if you were given a problem where you were said, okay, x is equal to a 5 minus a 9 over 4x, to solve it for x, you'd have to get the x's on the same side. We're trying to solve it for this highlighted thing, so you get the highlighted stuff on the same side. So all we're going to do is take that stuff, and by the way, these two lines are the same, except it doesn't have the highlighting stuff. So we're going to take this right here, and this right here, and all we're going to do is take this to the other side, because here you take that to the other side. Here you'd have to add a 9/4 x to both sides to solve it. So here we're going to add a 9/4 of our integral to both sides. So you take your 1 plus your 9/4 gives you 13/4 of your integral on the left side. Well, you added a 9/4 of your integral here, so that drops out, leaving you only with this stuff that's not highlighted with on the right-hand side. Well, you're trying to go ahead and just get your integral. You don't want to have a number in front. Well, basically, you need to go ahead and get rid of that, so multiply both sides with the reciprocal of 4/13. Now, all you have to do is distribute through. And you could leave it like that, or if you wanted to pull out your common factor of your e to the 2x and your 1/13, you could. Either one of those last two statements would be fine. And you ended up solving for your integral. And then there should also be a plus c, since you're dealing with an indefinite integral. So here's a page that basically says, okay, if you're integrating an x to a power times an e to a power, or an x to the power times sine, or an x to the power times cosine, let your u be that x to the power, and then let the other part be your dv. So these are just basically helpful hints for doing integration by parts. However, if you're looking at integrals that are x to the power times your natural log, or x to the power times your arcsine or arctangent, you want to let your u be the natural log or the arcsine or the arctangent, while your dv is that x to the power. Or when you're dealing with integrals of e to the power times your sine or e to the power times cosine, you want to let your u be the sine or the cosine and your dv be that e to the power. Those are just some helpful hints to help you get these right.